Hi, our application name is Elder Fitness. My grandfather is a residential committee director. Some of the elders in his committee do morning exercise, and sometimes they may lose their ways or encounter some danger. And my grandfather hopes us to develop an app for the elders to help them and make some functions about the morning exercise recording. So he makes some requirements listed as below. The first one is to record the daily and weekly data of the running and climbing stairs of the users and the stakeholders. And the second one is the application should send the current location of the elder stakeholder to his or her family to guarantee their safety when they encounter emergency situations or lose actions capacity.
Okay, as for the features of our app, there's a welcome page and get page. A user can register and count and log in. The app can track the working run map, and it can show the distance and time consumptions. It can record the total height of walking up and down the stairs, can compute the calories. And there's data visualization, which is formed by 5 charts. The order can click the emergency button to seek help to their families, and the app has an automatic alarm mechanism to keep the older user being safe. Next part is our advantages. First is deep understanding of stakeholder needs, and the second is commercial potential, and the third is highest level of UI polish. And finally is a solid evaluation procedure. Okay, now it's demonstration. This is welcome page with animation, and this is welcome web page to briefly introduce the functionalities of app. Okay, let's click start and go into the login page. In the login page, there are 2 buttons. First is register and then is login. When you click register, you should put your information to the system, and then you can sign up for account. So I already have account, so we click cancel, and I input the username and the password. Then I click login to go into the main page. Now it's time to show the running track functionality. We're using Map Simulator to simulate the people's running. There are 3 buttons here in this page. First is start button to start the running track. Second is record button to go to the data virtualization page. The third is emergency button. The elder can click emergency button to inform his or her relative for seeking help. First we click the start button. And then we change the map in Map Simulator as we are running. After we kill all workout, we click stop and submit data to the cloud. And now we click the record button to go to the data virtualization page. There are 5 charts here. First chart shows the running distance every day in weekly period. Second chart shows the flight climbed every day in weekly period. Third chart shows the calorie consumed every day in weekly period. The first chart shows the calorie proportion in weekly period. The last chart shows the calorie proportion in today's workout. Now let me show the safety mechanism. Firstly, let's assume this is elder's phone. If I click the emergency button, it will send a text to the beeping phone, and the elder family can know the elder is in danger and the location where elder currently in. Okay, as you can see, let's assume this phone is elder's family's phone. I already received the text message from this phone. So the content is, your family member meets emergency situation at 37 Garden PI, Carlton VIC 3053, Australia. He or she needs your help. This app also provides an automatic alarm mechanism. If we start running track and do not move in 3 minutes, it will automatically send text to the beeping phone. Okay, now let's start and wait 3 minutes. Okay, now it is already in 3 minutes. You can see this system automatically adjusts the elder. The elder cannot send the text to his family, so it sends the text to the beeping phone. Okay, this is automatic alarm mechanism.
The figure displays the system structure. The Android app is connecting to Azure Cloud and Google Cloud. Azure Cloud provides APIs for data storage and data retrieval. Google Cloud provides a map service to track running on the map. This figure displays the Azure database ER diagram. One-to-one relation. Table user info is used for logging and register. Table running track is used for fitness data record and data virtualization. In this app, 2 safety mechanisms are designed. Automatic safety mechanism is implemented by a time task which are used to check whether the user moves more than 50 meters every 3 minutes. If not, the emergency text message contains his locations will be automatically sent to his family member for seeking help. Another is manually safety mechanism that user can press the button to send an emergency message to his family member for seeking help. 3 sensors are used for this project: GPS sensor collecting latitude and longitude data, then mapping to the Google Map. A given GPS data, the Google Map service will return the location address if elder meets emergency. The returned location address will be used by SMS to send a text message to his family member. The barometers are used to calculate the flight kilometers. For calculating distance and flight kilometers, we make some researches. This formula illustrating the distance between 2 points. This is the Java code based on the formula. The first function calculates the distance between 2 coordinates. The second function accumulates all distances, then it will be the accurate totally walking distance. This formula provides a basis for calculating flight kilometers. Barometers can get the accurate air pressure. According to this formula, altitude can be calculated. Since the sensor data is very sensitive, the altitude value is always fluctuating in a certain range. By my dozens of experiments, 2 meters are the best for sampling rate. Use the altitude divided by 3.3 meters, which is a standard length for a floor. Then the flight kilometers can be accurately displayed. Finally, we use Git to manage our code.